Hello class. For today's lab, each team will be making pre-test predictions for failure loads, modes of failure, and create a test matrix. Good luck. Okay.
What equations do we use?
I know. We'll use Euler-Bernoulli's bending stress equations. FB equals my over I.
But what bending stress do we use for the F sub B?
Can't we just pick one?
I don't know. What you looking at me for?
How about dense number 1? How about dense number 2? No? Okay. I don't know.
Well, what about dense number 3? We got struct 1 there. What about that one?
I don't know, guys. You pick whatever you guys
I have no idea.
It's going to take forever.
Hey guys, I found this value of dense number 1 for F sub B is 2050. How about 2400? Danny, what do you think?
I like that one with the 4.
I don't like it. How about number 2?
Is it too late to become an English major? Oh, this is hard stuff.
Guys, what about our objectives?
Well, in collaboration with Team 3, we can test the effects of knot defects and pressure treatment on the ultimate strength of a 2x4 stud. We can test the weak axis and they can test the strong axis of loading. This way we'll have more control over the objective.
That sounds interesting.
That sounds like a horrible objective. I got it! I'm gonna go tell everybody. Then I'm gonna turn into a dog.
So can you explain again the test setup?
Yeah, I think I can manage that. So, we will have 3 simply supported studs spanning 48 inches in length. The load will be placed at exactly L1/2. And we can have 3 different specimens. We can have one control that'll be a very clean 2x4 stud, no knots, no physical defects. Then we can do another stud to test with knots, to test against our control. And then we can also test a pressure-treated 2x4.
1.21 gigawatts. That's pretty high for flexural stress. What do you think, Danny?
Way high.
Yeah, that's what you always say. Why, I gotta. Can somebody please help me here? Wow, what do we have here?
So the bending stress is obtained from the data tables, and plugging into the equation, we find also the inertia to be 0.984 and the y to be 0.75. Plugging in, we obtain the maximum moment, but we also can find the maximum load to be 220 pounds.
Okay, so what you're saying is if we take 1500 as our flexural stress, that gives us a P max for the control specimen of 220 pounds. For knotted wood, we know that it can decrease by up to 30%, so if we multiply this by 0.7, we get 154. Existing literature tells us that treated wood can decrease in strength by up to 30% as well. So we'll do the same thing to this figure of 220 and arrive at the same value. But gee jillikers, this seems awfully low for such strong wood.
Did it increase in size? Yeah.
Oh!
Yeah, it was at the knot. Right at the
It wasn't at the crack though. That's crazy.
So, our results show values that are much larger than our calculated values. Our control value broke at 1,344 pounds with a maximum deflection of 2 inches and an actual to theoretical of 6.1. Our knotted board had an 1,111 pound maximum load before breaking, a 0.7 inch deflection, and a 7.2 actual to theoretical ratio. Our pressure treated board broke at 1,859 pounds and had a maximum deflection of 2.5 inches and a safety factor, an actual to theoretical of 12.07. We found some new crazy strong wood.
Danny, look!
Not
Whoa!
so fast there!
It's Superman!
No, the S stands for safety, but thank you for asking. This is garbage. You're all a bunch of idiots. You forgot the safety factor. Man, thought I was gone, huh? Wrong again. Look at what you idiots have done. You assumed this 1500 was accurate. But look, what you found was a design value. Take a look at these, why don't you? The safety factor was built into that figure. The max flexural stress that this can experience in service is that. Therefore, you cannot predict failure. Oh, God. What you should have done, had you been smart as I am, Captain Safety Factor, you should have used Matsumoto's magical bell clay, why don't you? See, we have a braking strength of 5,000 psi, design value, and lo and behold, safety factor of 2.1. Oh, that's accurate. What that gives us is FB equals 5,000 times 2.1, 10,500. This is what you should have used, not this. What is wrong? What you guys made me so angry sometimes.
Using a new value that Captain Safety Factor give us with a safety factor removed, we get an FOB of 10,500, and then we back solve for P with the new modified calculations. We get a control stat of P max of 5031 pounds with a ratio of 0.88, and a knotted stat of 1071 pounds with a ratio of 1.03. And a pressure treated with a P max of 1859 pounds with 1.21. Thank you, Captain Safety, for your help.
No problem, madam. Is there anything else I can help you with? I'm Captain Safety
Can
Factor.
you please turn Danny back into a human?
No, I don't think so.
I don't like you anymore.
Yeah, that's not how it's supposed to.
It's going down. I'm yelling timber.